graphing 2D kinematics. In order to graph 2D kinematics, it's the same basic principles that you use for graphing 1D kinematics. However, the only difference is that now you need to break it up into X and Y components. This same principle was taught to you when you were given a general velocity and you had to again break it up into X and Y components by using trigonometry. You're always going to be graphing a projectile and it's always going to be in a position versus time graph. So, for example, if a purple zebra was to jump off a 105 metre high cliff as represented on the y-axis, and it was to jump 238 metres off of that cliff and then was to fall 543 metres, then this is clearly shown from the positioning, and then it would take 15.6 seconds in order to reach the floor. The way that you calculate these numbers is by using the 2D kinematic formulas which you've previously learnt. So if you were to look at these variables over here, you can see that with the v initial in the x direction and the v final in the x direction is going to be the same. This is because the x is always going to stay constant throughout the graph because the acceleration in the x direction is going to equal 0. The tricky part here is that the velocity, as you can see, is going to be constantly changing, which is shown by the v initial here is going to be 69.21 metres per second, and the v final is going to be 83.68 metres per second. Again, this is always going to be calculated through the 2D kinematic formulas that you've previously learnt. The time is calculated by looking at the 2D kinematic formulas that you've previously learnt, and then is graphed along the x-axis, as you can see here. The delta x is not going to be featured on this graph, however you can still determine it from those previous formulas. However, the graph is only just going to show the positioning in the y direction.